This learning target is I can graph logarithmic equations. We are going to graph using tables, and we're going to use our graphing calculator to find our tables. So our first equation is y equals log of the quantity x plus 1 minus 3. We're going to start with the TI, but then we're also going to bring in the Casio, since some of you have those. So I'm going to go ahead and get them both turned on. With the TI, I'm going to go to y equals, and I'm going to type in the equation. So log, notice that the parenthesis comes up automatically, x plus 1, close the parenthesis, minus 3. And for the TI, I'm going to use second graph, which is the table function, and notice that I've come up with x values and y values. On the Casio, I need to go to the main menu. I'm going to go here where it says table. So execute. I need to clear this particular function out and put in the one I want, which is log. Parentheses are required here. X plus 1. Close it up, minus 3. And I go ahead and hit execute. And noticing right here, it says TABL for table. So choose here. And unlike the TI, where it lists a lot of x values, the Casio only lists a few. However, I want specific x values. So the x values I want to use are 0, 1, 4, and 9. And the reason I chose those values, you cannot have this right here, x plus 1, cannot be anything less than a positive number. It can't even be 0. So I specifically chose 0, 1, 4, and 9 as my x's. In the TI, I'm just going to arrow to the x that I want. So when x is 0, y is negative 3. And in the Casio, if the number is not showing up, I can just type it. Notice that right here, it says x equals 1 and y equals negative 2.698. If you're looking closely, you notice that the TI says negative 2.699. Those are just rounding differences. Okay, so negative 2.698 is fine. For x equals 1, let me write it in the right line. Okay, for x equals 4, and I know there's a 4 here, but I just want to show you, if I type 4 and enter, it changes this top value here to 4. And looking at the TI, I have negative 2.301, and on the Casio, I have negative 2.301, so that you can see we are doing the same thing. And the other value I want is 9. On the TI, I'm just going to arrow down, and notice the x values down here are increasing. It says it's negative 2. So I have made a table with both of these calculators. I'm going to plot these points, 0, negative 3, 1, negative 2.698, which is closely negative 2.7. Here's negative 2.5. So I'm going to figure that it's probably about right here. 4, negative 2.3. So 4, negative 2.3, probably about here. And at x equals 9, y equals negative 2. Because logs are the inverse of exponentials, and exponentials grow very, very quickly, logarithms grow very, very slowly. And that's my graph of my first one. Okay. For my second example, I'm going to use a natural log. And again, I'll show you quickly on both calculators. So we're going to go put this graph equation into both calculators. For the Casio, I'm going to go ahead and hit exit. and that sends me back to the y equals table. I need to delete the equation that's already there, f2, f1. In the TI, I just go back to y equals and hit clear. Both of these calculators have an LN button. Make sure that you put parentheses around the x plus 2. And then I have a minus 1. Okay. On the TI, second graph to give me the table. On the Casio, I hit enter, table. There we go. So you can see both of these calculators work just as easily for a table. The x values I chose are x equals -1, 0, +1, 2, and 10. I'm going to go ahead and just use the TI here. I'm going to arrow to the -1, and it tells me that when x is -1, y is -1. When x is 0, y is -0.3069. When x is 1, 0.0986. When x is 2, 0.3862. And when x is 10, well, to get to the 10, I think it's actually going to be simpler just to type it in here. On the TI, I could have arrowed to 10. On the Casio, I type in 10, and I have 0.7917. So going ahead to plot my points now. -1, -1. 0, -3.069. So 0, I get the fact that that axis is a little crooked. Go right here. 1.09, so that's just barely above the x-axis, 0.09. Okay. When x is 2, we have 0.38. 2.38 is about here. And when x is 10, I have 0.079, so that's probably about here. Once again, we notice that this curve increases very, very slowly.